So good morning, everyone, and thank you very much for the chance to give this presentation. So the topic of my presentation is exactly on InSAR and photomonitoring and application for ground deformation. I would like to acknowledge my co-authors that you already mentioned. And let me start with a brief presentation of myself. I am professor at the University of Rome. I'm working at the Department of Earth Sciences. I'm lecturer of remote sensing and geological risk. I'm also the organizer of the international course on geotechnical and structural monitoring that is held annually in Italy since 2014. And I'm now member of Transportation Research Board Engineering Geology Committee and one of the founders of the Field Monitoring in Geomechanics Technical Committee of the International Society of Soil Mechanics. And I'm also founder of Legnica company, which is a company delivering remote sensing services based on innovative technologies for civil engineering and geological application. Legnica is about 30 qualified staff, and the purpose is exactly to look at management and control of natural hazards and land and infrastructures. And exactly what you know is to transfer technologies developed at the university into end users. So probably you're already aware about what satellite InSAR is. It's just a technology based on satellite radar images that are able to collect images every few days. Potentially since 1992, so it's like a sort of time machine of images that are available to the scientific and technical industrial community today. The good point of this data is that they can acquire in any weather condition because there are radar images, and thanks to this technology that is called interferometry, they are able to measure very accurate deformations. Photomonitoring is a little bit different technologies, but in a way with similar purposes. So the purpose is to allow to identify change and to measure displacement and deformations of object on the ground. And in this case can be applied by satellite images, but also UAV or ground-based. And let me give you a few words more about photomonitoring that is probably less known. Photomonitoring allows to derive change, so measuring what has changed over time in certain areas. As you can see here, with two simple pictures taken before and after, you see small changes that are easily identified automatically by proper software. And the same thing can be for if you have not just two images, but you have several images. What you can do, also taken with a ground-based camera, you can have a real movie of what is the movement. In this case, you can see this is a huge landslide in the northern part of Italy. At the same time, having several images, you can have a time series. So for each area or each point in your picture, you can derive this trend of deformation and identify the amount or the total amount, but also the time evolution of this displacement. So that's in some way the two technologies. I don't want to spend more time on InSAR as it's hopefully becoming quite famous right now. It's 20 years that is applied for application in different fields, including dam control. What I would like to focus a little bit is the differences between the two technologies. As already mentioned, the purpose of this technology is to provide similar results. So maps of change and deformation on the ground surface and on structures, but there are small differences. The first one is the source. Satellite InSAR just can use SAR images collected with a specific technical feature, with same orbit, with same angle of look. So it's quite demanding in terms of perspectives, but it's very, very powerful. Photo monitoring, on the other hand, can ingest and provide information with any kind of image. That is radar, optical, infrared, and from any kind of platform, so it can be ground, UAV, aerial, satellite. So any kind of image that is collected multi-temporally by photo monitoring can be compared to detect displacement and change. So more into detail about some features, what is the direction of movement that can be measured with a satellite InSAR. We can identify just one line of sight deformation geometry, while with photo monitoring we can see the direction of movement normal to the line of sight. So from this point of view, they are quite complementary, these two technologies. And regarding the capability to detect deformation, InSAR is very, very precise, can arrive to millimeter, in a few cases also sub-millimeter precision, if you look at long-term analysis, so in terms of trends, but has some limitation with large movements due to some problem of correlation. On the other hand, photo monitoring can be also measured from millimeter, probably a little bit less accurate, but on the other hand has no limits in terms of large movements that can be easily detected, and especially is much more effective on identifying change. And of course, if you look at InSAR, it's working in any weather condition because it's just using radar images. Photo monitoring, depending on the type of image that you use, can work in any weather condition. If you use radar images, if you use optical, if you have clouds or during the night, is not effective. What is good and what is not good? Satellite InSAR is very good for accurate detection of measurements of continuous displacement of structures or well-reflected ground. So when you have something that is reflecting very well the satellite images signal, you can measure over long term very, very small movement. And this is very useful for infrastructures. Of course, it's not good for impulsive movement. So when you have a sudden movement occurring in a short term between the acquisition of two different images, this is something that satellite InSAR can miss. On the other hand, satellite and UAV photo monitoring is good for accurate detection, probably a little bit less accurate than InSAR, but on the other hand can measure any kind of structures, even if it's not very reflective, because can use also passive images. And of course, it's very good on the contrary for impulsive movement, sudden change that can be easily and well detected by photo monitoring. I think now images and videos are more useful than words, so I'm going to present a few examples of application of these two technologies that from my perspective are not concurrent, are just complementary, and can be very effective, especially if used in a combined way. This is an example of photo monitoring application over a large basin where you can see a lot of stuffs, change of the water level, but also, for example, the presence of some sediment that you can see here changing over time. That can be a good indicator of the sedimentation into the dam. With the radar images, for example, on the other hand, you can look at the coastlines, and in this case, it's quite interesting case because we are in Africa, and there was this huge dam, and we identified this strange pattern, probably not easy to be understood by people not expert on this technology, but we saw this change of color, and looking more into detail, we realized that it was due to a 5 kilometers long crack into the ground that was easily identified completely in a remote way and then verified in the field. And the owner of this asset was not aware of this before this data were available. Already mentioned something about coastline monitoring and change of the coast. You can see here, for example, seasonal variations. That is something can be done very easily by satellite photo monitoring. While by InSAR photomonitoring, for example, like in this case, you see this basin, we are in the Alps, in a very high alpine environment. You can see this huge mass, this huge color that is from yellow to orange to red. All those points that you see over the picture are measurement points derived by satellite InSAR, and those going to yellow, orange and red means movement. So you can see small portion of slopes moving around the basin, but you can also see huge massive slopes affected by deep-seated ground deformation. So this is a nice picture that can be used for hazard assessment. And as you can see here, also the time series for each point can be derived, and this is very interesting because it can allow you to understand also which is the kind of deformation. Similar achievements can be achieved also with photo monitoring, comparing in this case just medium resolution images by planet scope, and you see this pattern of deformation of this huge landscapes in the United States and time series of displacement that can be derived. At the same time, we can control also the dam itself with this technology. This is an example also in Africa, and you see this dam, everything seems green except for a few sectors, so it seems that everything is very stable, and this is a very good news for the owner. This is another example. Here we are in Italy. This is an earth dam, quite small, with some issues for leveling measurements, especially in retrieving past data that were showing anomalous results. And so we decided to perform this back analysis, analyzing data of the last 10 years with high resolution radar images for InSAR processing. And as you can see here, everything seems quite stable except for a few yellow points. And what we did here was to compare also the data with leveling. So blue is leveling measurement and orange is InSAR measurement, except for some seasonal variation that is identified thanks to InSAR, because the frequency of data collection is higher than leveling that was performed almost every 6 months. In our case, we had data from satellite every 15 days. You see that there is a good match, a good correspondence between the two. And following this, also the National Authority for Dams decided to accept this kind of monitoring system as an alternative to leveling. Coming to this case, probably is known to some of the audience. This is a Tailings dam, one of the largest in the world. And this same analysis was performed by satellite InSAR using medium resolution analysis. And in this case, you see these patterns of deformation that can be easily identified. And once post-process, they can be able to provide what is vertical deformation on different sections, horizontal deformations on different sections, and also sections of movement. So you see this is a sort of section with different movements going on. Of course, not anything can be done from the sky. Sometimes it can be more effective to have a ground measurement system. And this is an example of photo monitoring applied to robotized monitoring system from the ground that is able to capture at 1 kilometer distance a small change, small faults on the order of a few centimeters. And so this is very interesting to understand what is the evolution of rock scarps, but also of concrete or earth dams. And of course, photo monitoring from the ground, I think this picture, this small video is very well known by most of you. This is the Brumadinho collapse in Brazil. And on the left, just the video, and on the right, what can be achieved using photo monitoring technology, just measuring in this case, as you can see, amount and direction of movement. That can be done, of course, in this case, but in any other case affected by this, also for small movements. Small movements can be detected also by radar ground-based technologies. In this case, it's a sub-millimeter deformation of an arch concrete dam due to increase and decrease of water level, as you see here. And if you look at the scale of deformation, we have between -3 and +3 millimeters. So you have really an accuracy of 0.1, 0.2 millimeters. So it's very, very accurate at short distances. This kind of data can be achieved by different instruments. What we developed in my research group over the last years was a software that is dedicated to process this data. At present, it's compatible with different radar produced by different manufacturers like IDS, Metasensing, Ecos. And this software is very powerful, as allow a lot of customization of analysis, and also in very complex situation with not good reflectivity, and is now used in a lot of cases also for dam monitoring. So I think this is enough from my side. I would like to thank you all for the attention, and I'm available for questions.